Okay, let's refresh our memory because I know your brains were also on vacation for the past 2 weeks. These are the skills that we need for today's lesson. Starting off, here we are simplifying f to the negative 7 times f to the 4th. All right? In order to do this, there's 2 steps. We can fix the negative exponent. Remember, a negative exponent is not like negative on the number line. It's a set of instructions saying that this number is not where it belongs, or this letter is not where it belongs. When you fix it, then you can cancel because those are both f's. Nick, you should be taking notes. Okay. So what is the answer? Raise your hand if you can tell me what the answer is. Austin.
F to the negative 3rd. Good job.
Okay, but we can't have negative exponents.
X to the 3rd. F to the 3rd.
So fix that. Fix that
F
answer.
to the 3rd.
No.
Negative F to the 3rd.
Negative,
Negative,
and then parentheses F to the 3rd.
1 over F to the 3rd. I knew it.
1 over
Oh,
f to the 3rd.
I hate this.
Okay.
Let's do
1 over f to the 3rd power. If I would fix the negative first, that means that f to the negative 7 actually belongs here. Then when I cancel, our rules for canceling or dividing were to subtract the exponents or just decide where do I have more f's. I have more in the denominator, which means all the ones at the top are going to cancel out, and I have 3 more in the denominator. And if there's nothing left in the numerator, that doesn't mean that now I've magically produced a whole number. There's a 1 in the numerator. Okay? All right, to multiply this.
That's easy.
That is very simple, but the fact is we have rules, okay? And so we need to remember what our rules are. What are we supposed to do? Because we're about to make things all crazy. But if you know your rules, it's going to be okay. All right? Well, here I'm multiplying things together.
So it's 8x, y to the 3rd.
Very good.
Good, I wrote it. Good.
We multiply our like items. Our whole numbers multiply together, our x's multiply together, our y's multiply together. For the variables, we add the exponents. That's the first rule. When you are multiplying 2 bases, you add the exponents. And so the answer to this was 8xy cubed. Okay? Now this is another rule that we need to know. I have a name for this. Does anybody remember what it is? Something to something. Raising a something to a something. Raising a power to a power. What do I do with the exponents in this case? You multiply them together. Okay, but is the whole number 3 an exponent? No.
That's 27.
Very good. That's 27. Okay? So we cube everything. And when we cube the variables, we're going to multiply the exponents together. That's a rule we need to know. Powers to powers multiply exponents.
So 27x to the 6th, y to the 9th.
27x to the 6th, y to the 9th is correct. Very good. Give me a second. Okay? When we were dealing with radicals, if I asked you to add the square root of 5 plus the square root of 20, can you just add them right now?
You have to simplify.
You have to simplify and make sure that they're alike first, okay? Because you can only add 2 things that are alike. Well, how do we simplify? All right, we simplify each radical and we add them only if they are alike. And remember that the radical itself doesn't, what? Doesn't change. Okay, so can you simplify the square root of 5 any further?
No.
The square root of 20 is this, right? So what does that simplify to?
2 to the 4 outside. I mean 2 squared.
5 into the radical.
Very good. Now can you add the two
Yes,
radicals
it's 3
together?
to the square root of 5.
It's 3 times the square root of 5. If you say 3 to the square root of 5, it means that your exponent is a square root of 5.
So there's an understood one for the
There's an understood 1 here. Very good. Okay?
That's what I said. Yeah.
There's an understood 1. All you add are the whole numbers outside. It's like saying 1 basketball plus 2 basketballs equals 3 basketballs. Okay? So the final answer here was 3 square roots
Times the square root.
of 5.
Oh, I keep saying it wrong.
Well, you good. It's both ways. 3 times the square root of 5 or 3 square roots of 5. Okay?
Fighting cats.
That's my child.
Would you show your children fighting and call them fighting cats?
No, she downloads all kind of crazy stuff from the internet. I mean, like pictures of not.
Wow.
Good one, Lucy.
Okay.
So funny.
All right. We also talked about when we introduced section 5.7 that fractional exponents are the same thing as radicals. So if we had x to the 2/3 power, we said you can write that as a radical. It's the cubed root of x squared. Do you remember that? Okay, very good. The numerator of the radical, and this is written as, okay, the numerator is the power of x, and the denominator is the root that you're looking for. So you simply take the bottom number and put it outside in the root. Okay? All right. Oh, we. You don't have to write this down. Okay? We just reviewed some laws of exponents. We reviewed how to work with radicals. We've also reviewed working with fractions. Okay? Oh, there's something we missed. This.
Oh, God, the only hard part.
My little clicker's not working for some reason.
Push the
We said when you're dealing with radicals in a denominator, can they stay there?
No.
This is very important. This is a very important step y'all need to listen to. And we also said if you've got a sum or difference of two things at the bottom, there's a special way to get rid of the radical in the denominator. Who remembers? Raise your hand. Don't shout. Jacob?
Multiply the top and the bottom by 4 minus the square root of 2.
Very good. Okay. Right there.
I knew it. I didn't even have to look at the board.
Wow. My little screen shade wasn't there. Okay. But what we're going to do is multiply the top and the bottom by 4 minus the square root of 2. Whatever's in that denominator, you do the opposite. If it's being added, you subtract. Why? What are we thinking of when we're doing this?
Cancellation. To get out the square root.
Difference of two squares, right? This is going to be the end result of foiling the difference of two squares. That middle term goes away. All right, well, if I multiply this times 4 minus the square root of 2, and this by 4 minus the square root of 2, all right, now we've got to go back to all our little rules. In the numerator, you've got to distribute. You've got the square root of 10 times the whole number, 4. So what will that give you? Jacob Taylor, turn around. Then you've got the square root of 10 times the square root of 2. What does that give you?
Square root of 20.
Square root of 20. Negative. In your head, can you reduce the square root of 20?
Yes. 2, 2, 5, 5.
Okay? In the denominator, when we FOIL this together, first times first gives us 16. The outer terms and inner terms are going to go away. So I've got to focus on last times last. And what's the square root of 2 times the square root of 2? 2.